Alright, today we're talking about angle bisectors. We've dealt with perpendicular bisectors, now we're going to talk about the angles. So, if I have an angle, we say that an angle bisector is a line, or in this case technically a ray, that splits an angle completely or directly in half. That means that the angle I have now is cut into two equal angles. That's what a bisector is. What this bisector theorem tells us is, if I pick a point on that angle bisector, it is equally distant from both sides that made up my original angle. And distance is judged with a right angle. So that's the image we're going to kind of see, that these two sides must be congruent to each other. So how we'll use these is we have a picture like this. We have an angle bisector. I know it's one because we had these two marked as being congruent. And what we need to then find is finding x and then finding one of these segments. Well, these two segments must be equal to each other based on the theorem. Therefore, I'm just going to set those two expressions equal to each other. So, 10x plus 7 equals 12x minus 14. I'm going to end up with 2x on the left. Adding 14 will give me 21 on the right. So x will equal 21 halves, or that would be the same as 10.5. And now what I want to do is to find BD, I need to plug that in. Now in the end, it doesn't matter which one, because we know they're equal to each other. I can plug in for either value. But in the end, I'm just going to do BD equals 12 times x, which is 10.5, minus 14, which should give me 112 as my answer for the value of BD. Now, there's another type of picture we could see with this. In this case, we're not given that we have an angle bisector. Not for sure. It looks like it could be. We have an angle that's kind of cut, but we don't know if it's cut in half yet. Well, however, we do know that we have two sides here that are equally distant to my original angle. And it kind of works backwards, same way that we've done before. So the angle bisector theorem said if it was cut in half, then the sides are equal. It works backwards. These sides are equally distant from my original angle. Therefore, this must be an angle bisector. Therefore, these must be equal to each other. So same thing, we're just going to set those two angle measurements equal to each other. 5x plus 23 equals 6x plus 14. I'm going to subtract 5x from both sides, subtract 14 from both sides. That means x will equal 9. And same thing before. If I want to find the angle, doesn't matter which one. I'm just going to plug in. 6 times 9 plus 14 is my angle measurement, which should equal 54 plus 14, which gives me 68 degrees because this is an angle. And that's how we set these up, pretty nice and straightforward.